Hello, everybody. Thanks, everyone,
everyone.
for attending this session. My name is Paul. I'm here with Tim, and we're going to share our experience, our perspective of how residents have experienced having air source heat pumps installed as a replacement for gas boilers. And this is following an SHDF demonstrator project that we delivered at MPH, and Tim was the retrofit coordinator on. This is generally going to be a positive story, certainly with some lessons learned that we're going to share with everybody. We are not proposing in any way that we know it all on this subject, and we'd really like to hear from the audience about similar experiences that people may have had and any questions. On the agenda for this session, me and Tim will just give a bit of context behind our organisations, and then we'll just give a bit of context into the retrofit programme that this is all relevant to. We'll talk a little bit about what our expectations were at the beginning of installing air source heat pumps and what we thought might be the risks, and then discuss a bit about how we've evolved our thinking to think a bit more systemically about a home energy system more than just an air source heat pump. And then we're going to explain how we engage with the households that have had air source heat pumps and go through a few examples, which we're kind of referring to as the good, the bad and the ugly. So we'll come to that towards the end. So I'm the Sustainability Manager at MPH, and MPH are the Almo to West Northamptonshire Council. We manage about 12,000 council homes on behalf of the council. They're generally urban council housing, and MPH and WNC worked together to deliver an SHDF demonstrator project. We completed 149 whole house retrofits, and these air source heat pump homes were treated roughly around the sort of autumn to winter 2021 into 2022. So those systems have been in place now for over a year, and that's kind of what prompted us to do this engagement, to see how the tenants are getting on with everything. I'm going to hand over to Tim to introduce himself and introduce Energy Specifics.
Good morning, everybody. So Tim Freeman, I'm Managing Director of Energy Specifics and Compliance Specifics. So Energy Specifics is technically a PAS 2030 installer across multi-measures, and Compliance Specifics sort of does what it says on the tin. We have a team of about, well, over 20 now just doing compliance for PAS 2035, and have experienced all the funded programs out there from SHDF, LADS, HUG, ECO, and we started very early on in PAS 2035, so we have a huge wealth of submissions to Trustmark and experience around the funded programs. With Paul and his team across the demonstrator and wave one, we've worked on about 600 properties across multiple measures, with many challenging archetypes involved in that. One of the key things for me on this project is we worked with a firm called Constructive Thinking Studio, who are a firm of chartered architects and retrofit designers based in Liverpool, who have been on this journey with us as well all through. And this stands out for me in particular because we've done the heat pump ready approach on many of the solid wall properties, and we'll come on to show you exactly how we've approached that and what it means. For me, you know, I cross both companies in terms of certification or accreditation and installation, and I think that as retrofit coordinators, of which I'm the lead on this particular project, just brings a pretty unique and broad perspective on PAS and how we deliver it.
Okay, thanks very much, Tim. Just to give a bit of context on the retrofit program this relates to, It was, like I said, it was an SHGF demonstrator project. We treated 149 properties through that scheme. 15 homes were fitted with air source heat pumps. They were all very similar in terms of their archetype and location. They're some of them are right next to each other. And they've all had essentially the same deep retrofit measures installed. So as a house type, they're very, very similar in terms of their space heat and demand, and you know, what we'd expect the performance to be in the homes. There was some really significant fabric improvements made to the home. As you can see from the picture, that's solid wall homes with EWI, high performance windows and doors, top up loft insulation, mechanical ventilation, heating controls, and solar PV as well. And really, we were taking this as an approach through the demonstrator to maximise carbon reduction and future-proof these homes. Like Tim said, we describe these as heat pump ready, but these are beyond that. They're what we almost call net zero carbon ready. And as a relatively small sample out of the 149, they're a bit of a prototype, really, sort of testing the boundaries of what's possible with a home that's almost 100 years old. And the EPC ratings that we got out of these properties were A rated. They're formally, well, according to the EPCs, they're some of the most efficient homes in the whole stock, which is not bad for almost 100-year-old homes. So in terms of our kind of expectations of what we thought we might find when we're replacing gas boilers with heat pumps, our expectations really were that alongside the deep retrofit, this would be a cost-effective home heating solution. We were very aware that the context of where you install a heat pump really matters. We wouldn't have put these heat pumps into the homes without the deep retrofit. I don't think that would have been appropriate. But we did expect that some households would probably find this technology difficult, and we kind of expected that the tenant journey might be rocky for some, and we were aware that there was a risk that if the heating costs were high, that we'd be having an impact on fuel poverty locally. Tim, do you have any thoughts you might want to come in to consider your expectations of how we started this?
Yeah, I'd agree completely with what you've said, and heat pumps are that they do have their challenges, but as we'll come on to discuss, and when we look at some of the other slides, my view on these, and I will put it out there that I'm heat pump pro. I think they're going to be in pretty much every house in the country in time to come. But I think it's most of the challenges around heat pumps are to do with behavioural change, and it's quite a big ask for ingrained behaviour that we've all had. Of you come in from work at 5 o'clock and whack up the thermostat, and your gas boiler responds, and you have a overly warm house that's actually being heated very inefficiently. We're effectively, by doing this deep retrofit approach with the heat pump program, we're effectively giving tenants new houses, and they actually need to learn how to live and work in their house, make the house work alongside them. There's a collaboration needed there. The house is the passive bit. It's the tenant that actually has the control, to a large degree, to how successful their relationship with a heat pump is going to be.
Thanks, Tim. This presentation really is about the human element. This is as technical as we're going to get with this diagram. We began to think about the home energy system as a more holistic system beyond just the heat pump. We've installed solar PV on these properties, and they've got something called an iBoost, which connects the solar PV to the hot water cylinder. There's a valent heat pump controller. There's a switchy thermostat in there. And so we started to think about this systemically. as a way to kind of get the most out of installing a heat pump, making the maximum benefit for the tenants. But I'm aware that a lot of the words on this probably is too small for many people to read, so I won't dwell on this slide.
I think, Paul, there's quite an interesting point on this, though, in that this is an idealized diagram for an installation, and on many social houses there's not necessarily going to be space for a hot water cylinder. So there are now some very small capacity heat pumps coming onto the market. I think 5 or 6 kilowatts is now the smallest heat pump you can get. You can get units that will literally go in a kitchen cupboard now. But this to me is an optimized system, which from the pictures of the house a couple of slides ago is perfect. And it's also worth just mentioning the solar PV element of this. The solar iBoost diverts excess solar energy into the hot water cylinder via the immersion heater. So there's no loss in that system, so it's 100% efficient. I'm sure everyone looks at retrofit assessments that are done and the recommendations that come up, and usually if a property comes up with a recommendation for PV, it will also suggest solar thermal. This system that we worked on with Paul, the diverter switch on the PV is effectively giving you two systems in one, because it will heat your hot water in the summer whenever the sun's shining and you're not using the electricity. But it also, in my mind, actually takes out a bit of a problem with solar thermal, which is it's at its most efficient when the sun is shining, which is in the summer, and its byproduct is heat, which the system has to get rid of to stay safe, because the more heat you put in, the higher the pressures in the system. So this effectively does that with electricity as opposed to hot water, and you get both systems delivered on that. And of course, it feeds into the heat pump as well. So this is a really good example of how a system could be set up.
Thanks very much, Tim. We're now going to go into a bit more detail about how we engaged with our residents on this. And this was, like I said, it was a fairly small sample of properties, but our intention really was to collect qualitative information from how residents feel about their air source heat pump, how they perceive the cost effectiveness. So we weren't really looking at how the technology works. We're confident that the technology works, and we're not here to prove or disprove that. We're interested in the people element of this, how people manage it. So in order for us to do that, we utilised a function of the switchy thermostat, which enables us to communicate directly with the tenants. We can ask very simple questions, which can then give us a very simple answer back. And we were able to use that kind of scripting process to ask the questions we wanted to ask and get a very simple response back. So we summarized those responses in this table, and this kind of gives us a very kind of good insight into how the residents are experiencing this across those 15 homes. So we were looking at, are the tenants comfortable? Did they have the system explained to them when it was installed? And would they like any support, and are they satisfied with it? Tim, can I ask you just to summarize what this feedback means to you? What does it tell you?
Yes, yeah, I think it's also worth saying, Paul, that you commissioned this survey externally, so it wasn't ourselves as the coordinators or NPH doing this. So, and I think that's really important, because I think that gives it there's no element of the tenants feeling they might have to say something because their landlord was asking the question. So I think it was a rigorous approach. I find this table absolutely fascinating. I think this sums up a whole load of dilemmas that we have with trying to do good retrofit at scale within the social housing sector, particularly, dare I say, at the last 4 lines, where we all struggle with tenant engagement, from even trying to contact them to book in a survey. And to me, that's an area that's really quite important, particularly when it comes to heat pumps, because we need, as I said before, there's a relationship between their new house and the heat pump that tenants need to understand and not feel overwhelmed or threatened by. The one for me is that are interesting here is the ones which are easy on the comfort in the house. So we've got line 5 and line 8, and yes, the installer handed over to them, but actually 5 is dissatisfied with that it's a cost-effective way to heat their home, and 8 is satisfied. As Paul said, and this is why this study is really fascinating, and you saw on the photographs, these houses are just about as identical as you could find in housing stock. So this is really relevant data to see how people's perceptions are, their experiences and perceptions are different. And there's lots of reasons that feed into that. But also in the last column, really only the people that really struggled with it, I suppose on balance, wanted any further help from NPH. So most of them sort of, it was a fit and forget and we're just going to get on with our lives type of thing, and that's challenging. What I would say about heat pumps, and I have some experience with them from a technical point of view, is that the system design, the system installation, the system commissioning and the system handover are all essential elements into a successful heat pump installation, and any one of those that isn't spot on can lead to responses such as we see in some of the columns here. And in some instances it can be something that's either not being communicated to the tenant or a technical installation thing that hasn't been set up or commissioned absolutely optimally. And I suppose my experience with this, having been involved in a number of installations, is ask questions. You know, these installers, the MCS installers, it's a very rigorous process that they have to go through to become MCS accredited and be able to install these, specify them and install them. And if a tenant has questions or an issue around it, the installer should be the font of all knowledge on this. As a coordinator, although I have my own knowledge on stuff, my role is to ask questions and to see, you know, is to help guide the conversation in a way so that we're trying to get to the nitty gritty of why people might be either not using their system correctly or not understanding it. So yeah, this table, I think these slides will be made available afterwards. I would thoroughly recommend you go through and read all of this because there's some fascinating insight and feedback on all of these. I think we can do next, Paul.
Okay. So after we did that switchy communication, we did make a few home visits and phone calls and spoke to some residents about both the positive and the negative comments. And the general kind of overview that we've got from these residents is the home is warm. The heat pump system is keeping the home a comfortable temperature, which is great. There has been questions about the affordability of the heat pump, and I would say there's an uncertainty here about whether that is relevant to the heat pump or the fact that we installed these as energy prices just shot through the roof, and whether that perception is it just that energy prices are unaffordable for a lot of people. Like the previous slide showed, you know, there's a wide variety of this meeting and not meeting the tenant's expectations in terms of a heating system that's replaced a gas boiler. You know, people will have an expectation what the heating system should do. For some people that's been fine, for some people it's not been so good. So we're going to go into a bit more of a deep dive into 3 examples, which we're calling the good and the bad and the ugly. And we're going to start on the ugly. So this is the output from the switchy data that's collected in the homes, and just I'm sure that this will be too small to read, but just to explain the graphs a little, the blue line is the internal temperature in the home. The red line is the target temperature on the heating system, and the yellow line is the outside temperature, so the weather temperature essentially. And what this household shows us is that they've had their heat pump running at a very conservative level, really, from a sort of 15 to 16 degree target temperature. And at some point, and this is January this year, they've made the decision that the system is unaffordable for them, and they've switched it off. We know from talking to them that the reason that the blue line has stayed relatively stable is because they've had some secondary heating, but clearly we didn't install these systems with the intention that a tenant wouldn't be able to afford to run it. So this is why we consider it the ugly. Tim, would you like to summarize how you perceive this data?
Yeah, I mean, this is the the cold hard reality of fuel poverty. So my understanding with this particular tenant is that they sort of have a 1 kilowatt electric heater in one room, and that's what they use. Now, one of those heaters could be 1 or 2 kilowatts, but the heat pump on this property, I'm guessing, was at least the 9 kilowatt. Now, immediately that's a huge difference in energy demand between a 9 and a 1 or 2. But 9 kilowatt heaters do not, air source heat pumps, I should say, do not run at 9 kilowatts. That's not the draw they have. That's the maximum startup that they will have to get the property up to temperature. So, once the property is at temperature, it should be running at, 2 kilowatts, 3 kilowatts, because it's a very efficient heat generator. So for those that don't know, heat pumps come with something called a COP, a coefficient of performance, which is rated over 12 months. So it includes winter and summer periods. And that's the amount of energy put into what these heat pumps can produce. So the reason they're very attractive is that most heat pumps have a COP, a COP of around 3.5 to 4.5. There are some outliers that are better, but not many. And that effectively means for every kilowatt of electricity that goes in, these heat pumps are producing around 3.5 to 4 kilowatts of energy out. So this is why, with the rise in energy costs, particularly around electricity, but with gas as well, obviously, heat pumps are now effectively costing about the same to run as a gas boiler, because they're on balance 4 times as efficient. The best gas boiler out there is 92, maybe 93% efficient. Many of these are running at 400% efficiency. So that's, we talk about heat pumps in isolation, but it's really important to think of, there's nothing else out there that is producing more than goes into it. It's sort of alchemy in a way, but most of Scandinavia are on heat pumps in very well insulated properties, and that's how they heat their properties. So, we're not really testing technology here. It's continually being improved, of course, but what we're trying to do is change perception and behaviour, and get them into retrofitted properties. And these properties, as I said, they're exemplars, in my opinion, of deep retrofit that is perfect for heat pumps. So this graph is, unfortunately, this tenant is in dire fuel poverty, and it was a choice between heat and eat, literally that. So they've turned it off, and live in one room in the property. So they have this facility there that can be turned on in the future, but unfortunately in this particular instance they're unable to understand or use the benefits of the heat pump.
Yeah, I think the word you used there that was key to me is perception, and the perception of this household is that the heat pump is unaffordable for them to run. Yeah. So for us at MPH now, we're engaging with this household quite closely to try and rebuild the trust in the household that this is a good system to keep their home and their family healthy. So it's an ongoing piece of tenant engagement for us. So I'll move on to now what we're calling the bad, and this makes quite a picture. Tim, can you talk us through what's happening here?
I can, yeah. So the absolute slap in the face on this graph is the red line, which is the target temperature. So this thermostat has been set to, by the look of it, about 16 degrees up to 30 on a, multiple times a day. Now this is a classic heat it up in the morning, heat it up in the evening programming schedule, in my view, with some tinkering around, because they're simply not getting the results that they expect. And this is exactly the behaviour that you'd expect in a gas heated property. So you have your gas boiler coming on in the morning to give a little boost to the internal temperature, and the same, in the evening when the household is occupied again. And it's categorically not the way to run a heat pump. Heat pumps are actually much more efficient when they're running almost full time, but in an optimized way. So again, perception. What you don't want to do when you insulate a home, as we've done here, we've effectively wrapped these homes in external wall insulation. And if you think about what that is doing to the building physics, it means that everything inside that insulation level, which is the old existing external walls, which are solid brick, and all the furniture inside the properties, the doors, the staircases, everything will attain a background temperature. And heat pumps work best when that temperature varies very little. So working a heat pump in this manner is going to lead to a house that doesn't feel comfortable, and B, some pretty extraordinary bills. I would dread to think what the bill was on this, because it's simply been reprogrammed. I'm guessing by the tenant. I don't think the installer would have allowed this to happen. They wouldn't have handed it over this way, because it simply wouldn't have been compliant. And it's the bad old behaviour of gas boilers. So this is a behavioural change and a perception change of how you should be using this, because these houses, when you see the good in a second, should be about the easiest houses to keep at a very comfortable temperature, and with a very good internal atmosphere and conditions for the tenants that are out there. As Paul said, it's extraordinary. We've got these properties up to very decent A's, which is tantamount to really good design and installation specification.
Yeah, the thing that stands out to me on this is that the actual temperature is almost never the target temperature. So the heat pump is always just going to be working full pelt to try and do something it's never going to do. So it just doesn't make any sense in the way that that's programmed. So I'm going to move on now to what we're calling the good. And I've called this the good in a sense that the household are happy and they're comfortable with what they've got, but I'm sure Tim is going to tell us that it's by no means perfect.
It's not perfect, in my opinion. I think I'm not sure I quite finished my previous point about wrapping the house. That everything becomes a battery. Think of the fabric of the house when you've done external wall insulation in deep retrofit as a battery. So but it's not a battery for electricity, it's a battery for heat. So the walls of the property become, in my opinion, the single most important element of that building once you've EWI'd it and you have a heat pump, because they will radiate back heat into the property even when the heat pump's off. So this is a country mile better than the previous slide. So they're setting their target temperature at about 21, and the default is at 15. Again, you'll see the actual temperature is very consistent, and that's good. So they've set some parameters here that are much more sensible But again, there's a cycle here of morning and evening, so it is much better. Their bills will be substantially less than the previous properties, but they're still not using this system optimally. And this is where the data is really, really good, because we can see this at a glance that, you know, they're close, but actually a little bit more engagement, in my opinion, with the installer would improve this even further for them.
Yeah, that's great. Thanks very much, Tim. We're pretty much at the end of the slide, and just in the interest of time, I think if we just close off, I'm going to ask Tim a final closing question. I know Tim has a heat pump in his own home, and I want to ask Tim how you manage it. How do you experience having a heat pump at home?
So as I said for clarity at the beginning, I'm a heat pump fan. I accept that they're not acceptable in all properties, but we have to get used to them. They're not going away. Gas boilers are going away without a doubt. For context, my property is a 1935 cavity wall, sort of 3 up, 3 down detached. I do have cavity wall insulation. I do have some very old double glazing, and I have an air source heat pump. I also have, as it happens, MVHR instead of extractor fans. So I'm keeping some of the heat in the house with that system. But I've had a heat pump for many years now. I'm on my second one. I actually changed it a few years ago because they'd got a whole lot better, smaller and quieter. And if you recorded my usage of my heat pump, and I should say I also have solar PV with a hot water tank and a diverter switch, exactly as the diagram that Paul has, that he showed us earlier on, I would have a red line on this graph. So I do not program on and off times on my heat pump. It is simply set to a target temperature. At the moment it's 18 degrees. In winter, when I come into the house, that feels really toasty, and the whole house is at that temperature, and the walls are warm, nothing is cold. Unlike with a gas boiler where you get very high temperatures at the radiators, which heat up that part of the room very efficiently, you're effectively being blasted with a lower level of heat all around. And that's why heat pumps work fantastically well with underfloor heating, which, if you're doing a new build, is absolutely the way to go, in my opinion, with air tightness, obviously. So yeah, I've been through this experience, and I've played around with it, and I've very quickly settled on actually the easiest thing to do. The best way to optimize this system is you just set a target temperature and leave it at that, and the system really, I just don't know it's there. It's very comfortable to live with, and yeah, my house has clearly over the years acclimatized to the internal temperature, and I'm sure it's leaky in places. It's an old house. I've never really done much to it, I should say, so it's not nearly as airtight or as sealed up as the properties we've done with MPH. But again, it's the more experiences that people put in around how they actually operate their systems, the better. And ultimately, for me as a coordinator, when I'm going back to evaluate projects that we've worked on, for me the single biggest qualitative piece of data that I can look at is actually to ask people for their fuel bills. So if I can get fuel bills for a year before the upgrade measures, the insulation measures, heating measures, whatever they were in combination, were installed, and ideally for a year afterwards, I'm actually not looking at what it cost. I want to see what the energy consumption was, because the fuel cost price rises are out of our control. But I want to see a substantial decrease in the demand that property has had, on the basis that the occupation hasn't changed. It's just the property's been upgraded. And this is why this particular study of these 15 properties, I believe what Paul's done here with having this data collected is actually just the starting point could be for a far deeper study, because they are so similar, and there's really powerful data in here.
Great, thanks very much, Tim. On that, that's the end of our presentation.